In cloud environments, exporting deployments allows administrators to capture existing resource configurations and replicate them across different services or environments. This process is frequently used in Microsoft Azure to generate consistent, repeatable deployments that reduce the likelihood of configuration drift. By extracting the definition of a running system, Azure enables you to create templates in JSON for Azure Resource Manager, ARM, or in Bicep, which is a more streamlined language. Although both formats ultimately produce similar infrastructure outcomes, each has distinct advantages regarding syntax, readability, and tooling. Exporting a deployment can be performed in multiple ways, including through the Azure portal, command line interfaces, or programmatic scripting. This capability is often leveraged for backing up complex solutions, sharing best practices across teams, or incorporating infrastructure definitions into pipelines. Understanding each export method specifics is essential for ensuring that generated templates accurately reflect the active environment and remain flexible for future modifications. Azure Resource Manager templates are JSON-based files that define resources, dependencies, and configurations for Azure services. They are widely used in production environments and contain clear mappings between various resource properties. However, the JSON syntax can become lengthy or cumbersome, especially in projects with numerous nested resources. Bicep was introduced as a domain-specific language that simplifies these template definitions. It offers a more concise code structure, improved readability, and a clearer way to express dependencies. Despite these differences, Bicep compiles directly into an ARM template. Consequently, the deployment process and runtime behaviors for both formats remain fundamentally the same. Teams transitioning from ARM templates to Bicep can benefit from a more straightforward development experience while retaining full integration with existing tools. Understanding the fundamental differences and advantages of each format helps establish which approach is best for a given architecture or organizational standardization strategy. The Azure portal provides a direct mechanism to export a currently deployed resource group or individual resource configuration as an ARM template. Within the portal, you navigate to a resource group, open the Export Template blade, or view a resource's details and select the export option. The resulting JSON output can be saved locally or within a code repository for tracking and version control. Clustered resources, such as virtual networks or virtual machines, typically appear in associated sections, denoting dependencies and parameter definitions that facilitate reusability. While the portal interface is helpful for beginners or small-scale demonstrations, it may generate templates that contain placeholders or default parameters, requiring some manual cleanup. For complex enterprise environments, the portal export is a starting point for further refinements. Despite that, its intuitive interface remains one of the fastest ways to create a functioning ARM template from an existing deployment. Azure PowerShell modules provide scripting capabilities that enable administrators to automate tasks, including exporting ARM templates. The Export Resource Group command is commonly used to obtain the JSON definition of all resources in a specified resource group. This command creates a folder structure and a template file that can be customized or incorporated into a DevOps workflow. By embedding this command in scripts, organizations can run export operations regularly or in response to configuration changes. This approach is beneficial when dealing with large environments, as it ensures consistent, repeatable exports without relying exclusively on manual actions in the portal. Moreover, PowerShell can capture parameters and output them across multiple resource groups, enabling a standardized template structure. While the exported files might need refinement to remove extraneous parameters or align naming conventions, the PowerShell-based process ensures a reliable foundation for creating or updating deployments using ARM templates. In addition to PowerShell, the Azure Command Line Interface, CLI, provides a platform-agnostic way to manage and export Azure resources. Commands such as AZ group export produce an ARM template capturing resource configurations within a specific resource group. This method is particularly useful for those operating on non-Windows platforms or in environments where PowerShell is not readily available. Like the PowerShell approach, the CLI outputs a JSON file that can be stored in version control or used in automated deployment pipelines. Although the resulting template may require further modifications, particularly around parameter definitions or property references, it offers a consistent representation of running resources. For teams already invested in scripting with the Azure CLI, or for those managing infrastructure across different operating systems, this export approach aligns well with established workflows. It also ensures an efficient mechanism for systematically capturing and reusing resource definitions. For complex scenarios requiring highly tailored templates, manual generation of ARM template files can complement export-based approaches. In certain cases, automatic exports may not account for organizational naming standards, custom role assignments, or advanced features such as resource loops. By examining an existing deployment and referencing official Azure documentation, administrators can craft templates that accurately reflect the environment's current state while adding or removing resources as needed. This approach involves opening a text editor, defining schema references, and systematically including parameters, variables, and resource sections. Metadata elements can also be appended to enhance template tracking and clarity. While manual creation demands a deep understanding of resource properties, dependencies, and best practices, it provides ultimate control over the final design. Teams generally employ a combination of export-based templates and manual modifications, yielding consistent infrastructure definitions that conform to specific business or technical requirements. Once an ARM template is available, converting it to a Bicep file simplifies its syntax and structure. The Bicep CLI offers a decompilation feature, typically invoked through bicep decompile template.json, which reads the JSON file and translates it into a Bicep configuration. This process attempts to generate Bicep code that captures resource definitions, parameters, variables, and outputs. Although the decompilation process eases transitioning between formats, the resulting Bicep file may require incremental adjustments, particularly around complex expressions or nested resources. Reviewing the code for duplication, renaming variables, and optimizing the module structure ensures clean, maintainable Bicep definitions. This conversion facilitates easier readability and quicker updates, especially for large-scale infrastructure. By consolidating multiple exports or manually created ARM templates into a single Bicep codebase, teams gain the benefit of a simpler, more modular language while preserving the original deployment's functional correctness. Before exporting a deployment, it is often important to verify the consistency and correctness of the existing infrastructure. Misconfigurations or partial deployments could lead to incomplete or invalid template definitions. Validation typically includes reviewing resource properties within the Azure portal, confirming dependencies, and ensuring that parameter values match the intended design. Additionally, running Azure Resource Manager template validations, either through PowerShell commands like test the resource group deployment or CLI commands such as AZ deployment group validate, helps identify issues that could disrupt template generation. By addressing these concerns preemptively, the final exported template is more likely to deploy cleanly when reapplied or shared. This step reduces the need for extensive post-export editing and ensures that the template structure reflects functional resources. In large enterprises, validation is often a standard requirement for quality assurance, forming a checkpoint that guards against inadvertently propagating inconsistent configurations through automation pipelines. After generating a template, be it through the portal, PowerShell, or CLI, teams typically refactor the output to promote reusability and clarity. This process includes removing hard-coded values in favor of parameters, grouping variables logically, and simplifying nested configurations. In Bicep, refactoring may also involve building modules that encapsulate related sets of resources, such as network configurations or specific security roles. As the development team tests and revises the deployment, gleaned insights help shape more generic templates. Rationalizing naming standards, parameter defaults, and resource grouping streamlines future updates and facilitates collaboration among multiple stakeholders. This is especially valuable in organizations that rely heavily on infrastructure as code, IAC, principles to continuously release and manage applications. By refactoring for reusability, minor adjustments can be made in a single module or template location instead of repeatedly throughout the infrastructure codebase, improving maintainability over time. Exporting deployments and converting templates play a critical role in managing Azure compute resources. Whether provisioning virtual machines, custom images, or container instances, capturing the full definition of compute services ensures uniform configurations and guarantees that security settings, network interfaces, and data disks conform to best practices. By plugging these exported or converted templates into an automated pipeline, developers can replicate an existing compute setup with minimal deviations, drastically accelerating provisioning tasks. Furthermore, the modular nature of Bicep allows a department to isolate compute definitions for repeated use across different projects. This synergy between exported templates and compute resource management fosters a consistent environment that meets compliance and performance objectives. The interplay between Microsoft Azure's native export tools, subsequent Bicep conversions, and advanced refactoring techniques can benefit teams responsible for large deployments of virtual machines, scaling sets, or container clusters in a structured, repeatable manner. Issues can sometimes arise during the export or conversion process, resulting in incomplete templates or errors within resource definitions. Common problems include missing resource references, mismatched dependencies, or unsupported property types in certain Azure resource providers. Administrators can troubleshoot these issues by comparing the exported template to the actual configuration in the resource group, verifying that all dependencies and link services are included. Additionally, analyzing error logs from Azure PowerShell or the Azure CLI can guide incremental fixes. Incorrect parameter assignments, type inconsistencies, or naming conflicts often appear in the export output, necessitating minor manual updates. If converting to Bicep, running the Bicep build command checks for compilation errors and highlights specific lines requiring attention. By systematically reviewing each resource and applying known best practices, teams mitigate deployment failures and subsequent uses of the exported definition. In this manner, error handling serves as a practical learning opportunity to refine future exports. When exporting or converting your Azure deployments, consider adopting naming strategies and organizational standards before generating the final template. Consistency in file names, parameters, and resource group labels leads to more intuitive source control and less confusion among team members. For repeated exports, store the generated templates in a version-controlled repository alongside application code to maintain an end-to-end view of the infrastructure. Techniques such as template specs can be leveraged within the Azure portal or the CLI to centralize commonly used ARM templates. Moreover, generating separate parameter files can help teams manage configurations for distinct environments, like staging or production, without modifying the core template. In Bicep, modular design is key. Break down large, monolithic templates into smaller files that reference distinct parts of the infrastructure. This modular approach simplifies maintenance and fosters reuse, while ensuring a stable, documented framework for new initiatives. Organizations employing continuous integration and continuous delivery pipelines benefit greatly from automated export and conversion routines. These pipelines can be set to run post-deployment or during scheduled checks to update ARM templates in source control and automatically decompile them to Bicep if needed. Tools like Azure DevOps or GitHub Actions can pull the latest definitions of compute resources, ensuring a single source of truth across an environment. Additionally, these tools support testing frameworks that validate exported templates, checking syntactical accuracy and redeployment viability. By incorporating template conversions into CI/CD, changes to infrastructure remain traceable and are subject to peer review, code scanning, and other DevSecOps best practices. This approach not only enhances collaboration, but also ensures that any newly introduced resource is documented and versioned in near real time. Over time, these automated workflows lead to streamlined governance and faster rollouts, with minimal manual effort required for template maintenance.